everyone. Good morning. Today we come back with another video on Python generators for large data processing. Python generators are a special type of iterable that allows you to create iterators in a more memory efficient way and more readable, right? They are particularly useful when you have large data sets or large streams of data because they yield items one at a time, only as needed, rather than creating the entire collection in the memory at once. So if you see that way, they can be called as lazy iterators or lazy evaluators, right? So they generate or produce items only when requested, and they do not generate all items at once. So when they pause, they retain their state in between different calls of the function. Now, because they yield one item at once, since they don't have to hold all the items in memory, generators are very efficient for handling large data set. Right. So this would not be possible. A generator can process like billions of items without storing them in memory, which is not possible with your other list data types. Now, if you see the syntax of it, it uses a simple keyword like yield rather than written in a function. So one generator function can have multiple yield keywords, right? So you have your next keyword in when you are trying to call the function, you have the next to call the function again and yield the next value that it is going to return, right? We will also see the implementation. So how we use the generator expressions is, apart from creating generator functions, you also can write generator expressions like you write for list comprehension. The syntax varies a little. You use parentheses instead of your square braces, right? So before we get into the implementation, we will look at the advantages of generators. First thing is, a big advantage is reduced memory usage because generators do not load all the items into memory at once, making them ideal for large data sets. Similarly, they are faster in terms of setup and execution because of lazy evaluation. Now, you can generate infinite sequences because each item is calculated on the fly. A famous application of using generator functions is to create your Fibonacci sequence. A main feature is preserving the state between calls. You can call a function today, like now in the code in the beginning, and probably recall the function later in the code, but between the different calls, the generator function will retain its state. All right, so let us see the implementation of it for a while before we conclude the topic. If you see this, this is a Jupyter notebook where I have defined a function with two return statements. Now, you might be wondering what happens if I give two return statements in a function. It doesn't yield any error, but it will not use the second return statement. The first return statement is like the end of the function. The value is returned and the function is gone until you call it again. So if I try to print it, you see that I can only print 1 and not 2, right? Now let us define a simple generator function with multiple yield statements. So generator function is almost like your normal function, except for the change in the keyword. Instead of return, you write yield. So now if you see, I define the instance of my function, and using the next keyword, I can print all the three values. Each time I use the next keyword and call the function, I will access each of the yield values. Do you see what happens if I run the code? Now, similarly, I can also write expressions, generator expressions like your list comprehension, right? Let us see how this happens. So let me start with an example of showing a list comprehension, right? So this is how I can print it. It just generates a list of values where when you try to use a loop and print all of them get printed. Now, the list comprehension is a list that holds all these values. Now, if you come to the generator expression, I write it in a similar way, but all I do is use a parenthesis instead of square braces. And see this, the syntax is very much similar. But if I try to print generator expression, I see that it is an object stored at a certain memory location. All the values are not stored at once. Each time I run the expression and I call the function, or I run the expression, each time I run, I will get one number, right? All the numbers are not stored together. Let us see another way in which I can call the function. I can create a generator function. Now, instead of using a next value, I can use a loop and a yield statement where, if you see, I can yield all the values. If I print it, so function 1 of 20 is a generator object, while if I use a loop, each time the function is called and one value is printed. Similarly, I will show you a small demonstration of how can you use generator function to generate Fibonacci series. So I am defining a function called Fibonacci where I give my limit as the input to the function. I'm declaring two variables a and b to hold values of 0 and 1, while a less than limit yield a. So I am printing only a each time the function is called, and I change the values of a and b. A will have the value of b and b will have the value of a plus b, right? So when you use a single declaration statement, both the variables are changed at once. And now if I try to run this code, you see that the Fibonacci numbers are getting printed. This possibility is not this level simple with your regular functions, right? So this is how you find generator functions very useful and memory efficient. With that said, so you will have to master the art of writing a right generator function. It will take a little time, but generator functions are more memory efficient. And that is why, and the preserving of state between the function calls is a bigger advantage. The variables will retain its states instead of getting reset. This is a big advantage of generator functions. So this is the end of Python generators for large data processing. See you again in the next video.